Good afternoon to all of you. Myself Dipti Jain, lecturer from GPC Mohali Khuni Majra. I am here to present a lecture on resistance and induction heating. First of all, let us discuss what is electric heating. So, electric heating is any process in which electrical energy is converted into heat energy, and it works on the principle of Joule heating, which tells us that an electric current through a resistor converts electrical energy into heat energy. So, basically electric heating is nothing that process which converts electric energy into heat energy. So, for the first of all, let us introducing electric heating is based on the principle that when electric current passes through a medium, heat is produced. For an example, let us take the case of a solid material which has resistance R ohms and current flowing through it is I amperes, and for T seconds then heat produced in the material will be H is equals to I square RT joules. Now, domestic application of electrical heating, as you know, electrical heating has a wide applications in domestic and as well as in industrial cases. So, first of all, let us discuss firstly the domestic applications of the electrical heating. First, it is used as a room heater for heating the building. It is used as an immersion heater for water heating, like the rod we are using in the domestic for heating the water. Third is, it is used as a hot plates for cooking, used as a geysers. The next is, it is used in electric kettles, electric iron, electric oven for baking products, and the last is electric toasters, etc. So, these are the most common domestic applications of the electric heating. The next is the industrial applications of electric heating process. Now, mostly these the electric heating is used for the melting of the metals. It is used in electric welding. It is used for the molding of glass for making glass appliances. It is used for the baking of insulators and for the molding of plastic component, and also for the pointing surfaces and for making the plywood. So, these are the most common domestic and industrial application of electric heating process. The next is, there are advantages of electrical heating over the other methods of heating. So, let us discuss all these advantages. First is, it is clean, it produces no pollution. Third is, response quickly. Fourth, it is accurate, control temperature can made easily. It is comparatively safe. Overall efficiency is much higher in this electric heating. It gives us uniform heating, highest efficiency of utilization, better working condition, and the low maintenance cost and less attention. So, let us discuss all these advantages one by one. The first is cleanliness. Now, electric heating does not produce dust, ash and soot, etc. So, it is a clean system and it also reduces the cleaning cost. The second is ease of control, as there is a accurate control of temperature can be provided manually or by fully automatic devices, so that any desired temperature can be maintained or it can be maintained constant. So, there is a ease of control with the electric heating appliances. The third is absence of flue gases. As you know, it is very clean process. So there is no any atmospheric pollution due to electric heating, because the electric system does not produce any flue gases. The fourth is high efficiency of utilization. Now in electric heating, the overall efficiency is comparatively high. So because the source can be brought directly to the point where heat is required, thereby reducing the losses. So in this way, these electric heating process have high efficiency of utilization. The next is, it has low maintenance cost and it requires less attention. Let us discuss how. Now electric heating appliances in general requires less attention, while their maintenance cost is negligibly small, thus resulting in very considerable saving in labor cost over the alternative heating effect. The next is, it provides us better working condition. How? In electric heating, the radiation losses are minimum. Therefore, the working condition with the electric furnaces are noiseless in operation. The next is, it gives us uniform heating. Now, by passing electric current through the heating elements, uniform heating can be produced, which is used for heating the whole material. The next is automatic protection. Now, the heating equipment can be protected against short circuit or earth fault easily by providing relays and switching system. The next is heating of non-conducting material. Now, by using electric heating process, we can even heat any non-conducting material. So, sometimes it is required to heat non-conducting material. So, it is only possible in electric heating, in which AC current at high frequency is applied to generate heat, and the example is dielectric heating. And the last advantage is, it is quick in operation. Now, in electric heating, heat can be produced very quickly by just switching on the power, which is not possible in other methods of heating. The next is the transfer of heat. Now, how the heat transfer from one medium to another or one surface to another. Now, heat is transferred from a hot body to cold body by the following methods. The first is, the main method is conduction. The second is by using convection, and third is by using radiation. So, there are basically three methods by which the heat can transfer from a hot body to a cold body. So, let us revise again. The first method is conduction, second is convection, and third is radiation. So, let us discuss all these three methods one by one. The first is conduction. This phenomena takes place in solid, liquid and gas. In this method, heat flows from one part of the body to the other part of the body. Now, the flow of the heat depends upon the temperature difference between the two bodies. That is, heat transfer is proportional to the difference of the temperature between two phases. Now, no actual motion of the molecules is taken place in this process. So, basically what is conduction? It is basically that process in which heat flows from one part of the body to the other part of the body, or you can say that if there is a temperature difference between two bodies, then there is a transfer of heat between the two bodies, and that transfer of heat is basically due to conduction. The second is convection. Now, this phenomena is basically related to liquid and gases. Means in solid there is no any transfer of heat by using the convection process. Now, heat is transferred due to the actual motion of the molecules. So, the main example is immersion heater, that is a rod we are using to heat the water in our domestic purposes. Then third is radiation. Now this phenomena is related to or confined to surfaces. Now radiant energy emitted or absorbed is dependent on the nature of the surface. Means there is a transfer of heat from one surface to another surface. Now condition is that both the surfaces must at different temperature. Now one must at high temperature and another must have low temperature. So whenever there is a temperature difference between any two surfaces, then the heat must be transferred from one body to another body by using radiation process. So this mode of transfer of heat is known as radiation. The next is classification of electric heating. Now basically the electric heating can be divided into two categories depending upon the frequency. The first is power frequency heating, that is heating on frequency that is 50 hertz or 60 hertz. The second is high frequency heatings. Now under power frequency heating again we have two methods, resistance heating and arc heating. Now in high frequency heating again it have two methods. First is induction heating and second is dielectric heating. Now again let us discuss. Now this resistance heating is again categorized into two types. The first is direct heating and second is indirect heating. Similarly arc heating is again categorized into two types. The first is direct arc heating and second is indirect arc heating. Now in induction heating, there are two categories. Now first is direct core type induction heating and second is coreless type induction heating. So in this way let us discuss all these methods of electric heating one by one. Now first of all let us classify the heating methods on the basis of temperature. Now, low temperature heating is up to plus minus 400 degrees centigrade. Now if the temperature ranges from 400 centigrade to 1150 centigrade, then this is known as medium temperature heating, and if the temperature is above 1150 degrees centigrade, then this is known as high temperature heating. So you can memorize temperature up to 400 degrees centigrade, it is known as low temperature heating. Temperature ranges from 400 to 1150 degrees centigrade, it is known as medium temperature heating, and the temperature above 1150 degrees centigrade is known as high temperature heating. So electric heating again the main two types, power frequency at 50 or 60 hertz. The second is high frequency methods at basically 5 to 500 kilohertz. Again power frequency is of two types, resistance heating direct or indirect. Now second is arc heating, it is again have two types, direct arc heating and indirect arc heating. So resistance heating is based on the principle that of I square R effect, that is it states that whenever current I is passed through a resistor R of the material, heat is produced because of I square R losses, because of the drop, there is a drop. So the generation of heat is done by electric resistor carrying current. So whenever there is a electric resistor in the circuit, there is a formation of heat in that circuit because of the drop, and that drop is I square R. So characteristic feature of heating element, basically that heating element must have high resistivity. So high resistivity means it require very small wire to obtain that temperature. it must be able to withstand high temperature without any deterioration. Third is low temperature coefficient of resistance, means resistance must not vary with the vary in temperature. Now otherwise it must have high starting current. Now fourth is positive temperature coefficient of resistance, and fifth is it must free from oxidation at high temperatures. The first method of power heating is direct resistance heating. So you see in this diagram, first of all, these are the two electrodes. This is a container in which we have poured charge, means the charge is that material which we want to heat. This is a charge, this is a furnace, these are the two electrodes, and supply is given to these two electrodes. Now if there are two electrodes in this diagram, then we must give DC supply or single phase supply, and for the three phase supply we require 3 electrodes. Now we have poured some high resistant powder. Now this is a special case. Now suppose if the quantity of this charge is less in this jar, so to avoid the short circuit we have poured high resistance powder over the charge. Now see here, the electrodes and the charge are in direct contact with each other. That is why it is known as direct resistance heating. Now see, it is accomplished by the dissipation of an electric current in a material. The second, material to be melted is placed inside a furnace with electrodes in the walls. Alternating or direct electric current is then passed between the electrodes through the material. And last is, resistance losses are dissipated as heat, causing the material to melt. So consider this is a furnace in which we have poured charge. Now charge is that material which we want to heat. Now here we have two electrodes that are immersed in this charge. Now whenever we give supply, single phase supply or DC supply to these electrodes, now these electrodes produce heat. Now we have poured some high resistance powder over this charge for the special case when the charge material is very less. Now in order to avoid the direct short circuit, we have poured some high resistance powder. Now advantage is it has high efficiency, it gives uniform heat and high temperature. Now high temperature because the charge and the electrodes are in direct contact with each other. So that is why high temperature is obtained. Next is application. It is mainly used in salt bath furnace and water heaters. The next is indirect resistance heating. Now in this indirect resistance heating, here we are using high resistant material. Now this is a charge. Now see, this high resistance wire and charge, they are not in direct contact with each other. Now here the heat is transferred to the charge by two methods, either by convection or by radiation. So in this method, the current is passed through a highly resistance element which is either placed above or below the oven depending upon the nature of the job to be performed. The heat proportional to I square R losses produced in the heating element delivered to the charge either by radiation or by convection. Now both AC and DC supply can be used for this purpose at full main voltage depending upon the design of the heating element. Now, application, because the charge and the heating element, they are not in direct contact with each other, so the temperature obtained here is comparatively less than the direct heating method. Now, this method is used in room heater, in bimetallic strip, used in starters, immersion water heaters, and in various types of resistance ovens used in domestic and commercial cooking. Now, next is, let us compare these two methods, direct heating method and indirect heating method. Now, in direct heating, electric current is passed through the body that or the charge to be heating, means we can say that the charge and the electrodes are in direct contact with each other. Dielectric heating have high efficiency because high temperature is obtained, and it is used basically in electrode boiler for heating water and for the welding purposes. The second is indirect heating. Electric current is passed through highly resistive material, that is the heating element, placed inside an oven. The heat produced due to I square R loss in the element is transmitted to the body, and the mode of transfer is either by convection or radiation, and it is used in room heaters and used for domestic and commercial cooking. Now, there are some causes of failure of heating elements, and these main causes are, there may be a formation of hot spots causes the failure of heating element because of oxidation, there may be a corrosion, and there may be a mechanical failure by which the heating element get fail. The next second category of power frequency heating is arc furnace. Now, an electric arc furnace is a furnace that heats charged material by means of an electric arc. Now, there are two common types of arc furnace. First is three-phase furnace and second is single-phase furnace. Three-phase furnaces are used in the production of alloy steels, and similarly the single-phase furnaces are used for the manufacture of grey iron casting. Three-phase furnaces are used for power rating from 250 kVA to 10,000 kVA, and the capacity is up to 25 tons. Generally, graphite electrodes are used as they are subjected to volatilization. They are to be replaced. Now, the arc temperature is between 3000 to 3500 degrees centigrade, so that the process is carried out between 1500 degrees centigrade to 2500 degree centigrade. The next is, again the arc furnace is of two types, direct arc furnace and indirect arc furnace. Now, first of all, let us discuss direct arc furnace. The arc in the direct arc furnace, now see, this is a diagram. Here again we are using two electrodes for the single phase or DC supply. Now, this is a charge which is to be heated. Now, this yellow color is showing us the arc between the charge and the electrode. Now, for the three phase we must use three electrodes. Now, the arc is struck directly with the charge when a current flows through it and produces intense heat, which results in high temperature. Now, although some furnaces up to 100 tons are made, generally furnaces up to 25 tons are in general use. Since the current is moving through the charge, so the steering action is automatic and gives a uniform product. So it is used for alloy steel manufacturing and gives a purer product. So see, when we will give the supply to the electrodes, the current will flow through these electrodes via this charge. Now here the arc will produce. So because the charge is in direct contact with this arc, so high temperature is obtained, and also the current passes through this charge. So this will provide the steering action. So the current will provide the steering action. So the uniform material is obtained, or you can say that the purer product is obtained from the direct arc furnace. And here the temperature obtained is very high, because the charge is in direct contact with the arc. Now advantage, it produces purer products. It is very simple and easy to control the composition of the final product during refining process. Disadvantage, it is very expensive, and the application is, the most common application of this type of furnace is to produce steel. Now next is indirect arc furnace. Now here, as the name here the arc and the charge to be heated, they are not in direct contact with each other. So the heat from the arc is given to the charge by radiation method. So the electrodes are inserted from the sides, and the heat produced is transmitted by radiation to the charge. As there is no inherent steering action, because there is no any movement of current from the charge, so there is no any automatic steering action in the indirect arc furnace. So the furnace should be rocked. So this furnace is used for only single phase supplies. Also the capacity of the furnace is limited up to 100 tons. The melting of the non-ferrous metals is mostly carried out in this type of furnace, and in both type of furnaces large quantities of electrodes are used. So see, these are the two electrodes that are injected into the furnace from the sides. Now the charge, now this is the charge which we want to heat, or you can say that this is a molten metal as a charge which we want to heat. So this is a refractory lining, so that the heat cannot escape from this furnace. Now here these are the wires through which we give supply. Now when the arc is produced between the two electrodes, this heat, now the heat then be transferred to the charge by using the radiation process. So here the temperature obtained is less as compared to direct arc furnace, and also the main disadvantage is here there is no any automatic steering action. Application. Now the main application of this type of furnace is melting of non-ferrous metal. The next is high frequency heating. This is the second type of electric heating process, high frequency heating. Now the major difference between the other methods of heating and the high frequency heating is that in the power frequency heating, the heat is transferred either by conduction, convection or radiation. But in high frequency heating, the heat is produced due to eddy current loss and dielectric loss. So the heating process used to heat conducting material and ferromagnetic materials is called induction heating, and the heating process used to heat insulating materials are known as dielectric heating. So again, the types of